like you said before, we are doing like a benchmark for full pipeline of financial workflows with LLMs. Um, so before our work, I believe there are lots of like previous work doing benchmark for financial tasks like trading or like doing problems for CQF or CFA and etc. But we believe those work are good, but we believe that we want to do something that's more realistic. We want to connect more to the real life for basic financial tasks like auditing, accounting, or like consulting. Because the financial task is very difficult. It's very labor intense, low to zero error tolerance, especially for auditing. The data is very fragmented. We cannot access the fundamental financial data, like the transaction data, the purchase or sell receipt for companies. We tried to connect with some companies and ask if we can get your data. We want to like do task for LLMs, but they all say no. And there are not a lot of technology tools. I know there are some OCR like SaaS or software tools for helping companies to do accounting job, but not very intelligent. The motivation of this task is very strong, like it's very important. And some companies, like the big tech companies, are trying to do this task. They want to replace some of the labor in accounting or auditing with LLMs because they think LLM shows promising capabilities. So um, we just want to prove if it is true. There are three main modules in our work: the fine simulator, the fine suit, and fine evaluation. So the first part is we create a sandbox environment for operating the companies. And the second part is we create some task for four sectors, and we evaluate the LM performance in like accuracy, token, arrows, and simulation. The fine simulator. This is my favorite part because um, previously I really like operating games like Civilization or Skyline, I guess. It's just like as a player, I can like purchase and sell to the customer, generate profits, and prove I'm the best CEO in the game. So Fine Simulator is actually the same idea. We simulate an operating like environment. We have different type of companies, like five type. Some are very capital heavy. The unit price is very high. They cannot sell a lot, but each unit profits is very good. And some companies, like the consulting company or like sales company, their unit price is low. They can sell a lot, but their selling sector's cost is very high. We want to use this simulator to like simulate every scenarios in operating the companies. We can get different type of data, and the users can expand it to other scenarios. If they can do like hotels companies, they want to test how their companies operate in some specific scenarios, they can use our simulator. And it actually solved the data problems. Um, so the idea is through this operating process, we can generate the fundamental data like transaction records like the receipt, the sales sector's cost, the operating sector cost, all random, but in a logical way, in logical numbers for this sector's number. The asset data, the operational data, the financial data, and we can create our financial statements through this transaction data, like the income statement, balance sheets, and cash flow statement. This is how we get the data. After we get data, we create the tax suit. Actually, four sectors. The first one is financial literacy. Some people think, and some author in our team think LM is not able to understand the fundamental task. Like they might not understand the turnover rate, what is the liability means. But after we test, it turns out that all the LM perform really well in the basic financial literacy. They can understand what is finance, what is auditing, those basic tasks. And then we create 49 job in accounting. Like if you can generate the liability number through our basic transaction data, what is the liability consist of? Can you sum up those numbers? Those basic tasks. And auditing is that we manually add some arrows in our transaction data, in our balance sheet, to see if the LM can find out those logical errors in this financial data through through transaction data, receipts, and etc. Consulting is basically, can you can you can you calculate what is the ROA, what is the ROE, what is the gross profit margin through our transaction data? So what we are trying to do is create a task suite that is realistic, as realistic as possible. Yeah, like we said, the instruction for different types of companies are all the same. The input is different for different tasks, and the output is how the LM perform in those tasks. And we have a template. So basically, for different tasks, we give an example to LM and problem solution for this example, so that they will know what task they are performing, and some instruction and our problem and JSON format for them to output their solutions. The experiment results, we test several models like O3 Mini, GPT-4 Mini, and Cloud 3.7. And it turns out that LM demonstrates strong basic financial literacy. They can understand and how models can achieve like 100%, even though we make a lot of rounds of experiments for financial literacy. There are not a lot of variety. And multi-step task and source integration remain challenging for GPT 4.1 Nano and GPT 4.0 Mini. These two models perform not as good as O3 Mini, but O3 Mini is not so good so that we can directly deploy in the industry. The realistic financial services are still very challenging, like the accounting, auditing, especially for auditing. The single task, they perform not good and still struggle with multi-step reasoning or multi-source data integration. When we try to make them integrate three different financial statements to generate a number, the thinking process stop at one step and just generate a number randomly. So in the future, for people who want to like actually create or train a model that's specifically doing a fundamental financial task, they can like improve on the multi-step reasoning or multi-source integration performance. And auditing capabilities is the worst among these three tasks. They rely on explicit patterns and very weak in isolated anomaly detections. And the tokens, not high token usage can output high accuracy is not very related. It really depends on the clear reasoning on the response and efficiency rather than token consumptions. And different companies comparison for good performance LM like O3 Mini or Cloud 3.7, there are not a lot of variance among different companies, but for GPT 4.0 Mini, 4 Mini, it actually shows a different performance. And for company's operation duration comparison, um, in in the first round of experiments, we make the companies run for short amount of time, like 3 months or 4 months, so that the transaction data will not be very long. It's easier to generate like the accounting, financial statement, or like doing auditing. But once we get longer the operating process and longer the transaction or like the receipt list, their performance becomes worse off. And the failure cases, there are lots of failure cases, but we try to generate a more like general failure cases for LMs. Um, One of the reason is there still exists domain knowledge gap. They might have a general understanding what is liabilities, but when it comes to actually adding up a small sectors like the sales, the fixed assets, or like the cost, the selling cost, the operating cost, they don't know how to do the logic. So there still exists domain knowledge gap, and critical data are missing. They might miss some of the data. They cannot get a whole picture of what the calculation process should be. And floating point arrows, we want them to have we try different cases. We trying to like you can give us a integer, or like you can give us like point zero, like the floating point, but they it seems that they cannot obey this rule, and a lot of errors happens in floating point error. And the other one is the reasoning consistent error. Uh, it might relate to the LLM capabilities. It's not like they have general misunderstanding of the what the task should be. It just they cannot do good reasoning. And that's all. We have all the GitHub link in our paper, and we welcome any feedback in our work. We can always improve this work.
So thank you so much for your presentation. I believe that was the end of this, right?
Yeah, yeah.
Okay, cool. So I have a few questions, but if there's anyone in the audience who has any questions, please go ahead.
Yes, I
Um,
have a quick question. So,
Yep.
yeah, first of all, like, thanks for your talk. Really interesting topic. I think this topic has a lot of potential out there. I'm really interested about like the analysis of the reasoning failure cases,
Yep.
because like this is what tell us like what to do next, right? How to improve the models and so on. So I wanted to ask you, like, what is the most common error that you found, or what is the critical thing that we have to address?
So there are different type of reasoning errors. One of the most obscure error that we found is they a lot of reasoning. Like one step, they calculate the number, and the second step they calculate another number. But when it comes to sum up the whole picture, the complete steps to give us the solution, they just seems like they lose their memory. They sum up a different numbers um, as they calculate previously. Oh my God. Sorry, my room. Yeah. And another thing is when there are multi-step reasoning, like the auditing, they need to find out what is the transaction data is, and so that they can have a logical understanding what is the balance sheet number should be. They cannot understand, even though they understand what liability is, they don't know how to calculate those numbers. Those logical um, thinking is wrong. And these two main errors.
Okay, so then just to paraphrase and see that I understand well, is like the problem is like the reason in itself, right?
Yeah. I'm sorry, can you say that again?
Uh,
I didn't
so
understand.
sorry, no, I mean like then the problem is like the reason in itself. So, for example, mathematical problems like summing or doing some multiplications wrong is not a problem because we can use tools to solve that. Domain knowledge gap is also not a problem because we can connect to manuals, to accounting books and get information. But the problem is how to integrate the information, right? How to logically think with what we have, how to process the things, right?
Yeah, yeah. Like the calculation error. I'm not talking about their calculate is wrong. It's just they missed previous steps. They
Yeah,
missed previous step reasoning. And for the following calculation, they use different number or they use different
right,
like equation. Yeah.
right. So we cannot fix this with tools.
Uh actually uh I haven't found out a solution to solve this problem.
Yeah, actually, I was gonna ask you now that like, how can we solve this problem? But yeah, you already answered. It's an
Um
open problem.
We're never gonna solve the problem.
Maybe we can create a template. Like you need to follow these rules, these rules, these rules, and
Yes, yes.
maybe that would be better. I haven't tried. I don't know.
Actually, I wanted to ask you this too. Like, do you think there is like some kind of uh, template or format to solve all these problems? Because like I know there is another paper. It's called FinChain. So it's like
Mm,
the great chain of thoughts for financial problems too, and they create some kind of template. So a
yeah,
problem can be solved in multiple ways.
yeah.
Many different problems follow the same kind of template. Do you also observe this in your case?
We didn't design any templates in doing this task, but um I would say that will be better and that will improve the accuracy. But in real life, there are multi-source data. It's not like a Excel file that have all the transaction data. They are multi like source. You might have like photos, Excel or like PDF. Um, the templates cannot solve all the scenarios. We Once we have templates that you need to follow these rules to give us the number for liabilities. But when it comes to multi-source data or some like special case, it cannot still perform well.
Yeah, yeah.
Yeah,
Yeah, I'm also using LLM with some unstructured data. And the typical way I use it is to use LLM for extracting kind of structure from unstructured data first.
yeah,
In a sense, kind of putting a template around the unstructured data. And once we have a template or some kind of a JSON structure around the data, then we can essentially rely on traditional coding.
yeah.
Um, so yeah, I wonder if such a separation will make sense here as well.
I would say yes. I would say if we have a template, we have a constructed data, or we use like OCR tools to like um, pre-constructed data into Excel or in a PDF that will actually improve the performance in these circumstances, like in doing this task. But in real life, there are still concerns. I would say it will be better. It will not, but it will not solve all the like problems.
Mhm. Mhm. Yeah, thanks. I have some more questions if no one else has any questions. So I was wondering about so typically how companies play around balance books or financial data is by using complex structures around the company, right? So one company is owning another company, and this can kind of go on like that, right? And
Yeah.
sometimes there's a cycle, right? It becomes a little
Yeah.
bit difficult to follow what's happening here. So in this case, you're looking at a single company cases, right? Instead of relations of
Yeah.
different companies.
Yeah. Um, we still consider this case, but
Ah, okay.
not in a very comprehensive way, because they are not like multiplayer in our environments, just one player. We have a logic in like owning money, or some companies own your money. We just have a number. Like some companies, like the capability heavy companies, like the manufacturing companies, they have very high debt, like from the bank or like for their partners. And for different companies have different like um, uh, patterns in debt. We consider these circumstances, but we did not consider like when I'm gonna pay back, what is the uh, company strategy in paying debt or owning debt because there are interest for having debt. It will definitely be considered in the future to make a more comprehensive version of this work.
Mm-hmm, mm-hmm, mm-hmm. Okay. I have some factual questions, like low-level questions about the data generation. So I was
Yeah.
wondering if you created the simulator by yourself.
Yeah.
Oh, I see. Okay.
Yeah.
Ah,
Sorry. Different different
yeah.
slides.
That was your favorite slide, right?
Yeah.
Um, and how did you how is this is this also based on LLM somehow or
No, we have like in our team, we
yeah.
have like Ai and Se CHK and Hong Kong University Science of Technology. I think Cui is a incoming PhD student in finance, and Jing Han is a accounting master. So they have working experience before. They help us to create the environments because I don't know anything about finance or accounting, the logic. So they help us to create this environment. We try to be as realistic as possible, but um, not very comprehensive, I guess. Not like includes all the sectors or scenarios. But we create from scratch all the scenarios, all the logic by ourselves. We did not like um, there are no previous work in this simulator. So yeah, we created by ourselves.
Mhm. Okay, thanks. And that's very impressive. Um, yeah, so I was wondering how you're gonna sell this to, let's say, companies or consultants. Um, do you imagine this as a kind of a replacement for kind of uh, tax consultant or financial consultant, or do you think of it more as a kind of an aiding tool for these experts?
Yeah. So as the AI agents are popular, getting
Mhm,
more popular in like the in China, there are lots of AI agent companies doing this task, using LLM to help you do your personal finance, like do you like accounting, be your accountant, personal accountant. But after we evaluate the performance, maybe we did not do templates or RAG and etc. But in my point of view, it still takes a long way
mhm,
to actually deploy into the industry. Um, but I see future because they can actually perform some of the accounting auditing
mhm,
job because I did not quite believe it in the first place when we start this work. But as we do more experiments, I see the potential of these models.
mhm. Because of the inherent knowledge in the models regarding.
Yeah, yeah. We did not make any like fine tune. We just call API and give instruction. So
Mhm, mhm,
if they can do some of the tasks, it's very impressive.
mhm, mhm.
Yeah.
Yeah. Um, okay, I think about it from my side. I guess that would be also kind of close to kind of finishing the session because we have only one speaker. I think 30 minutes is kind of the right ballpark for the
Yeah.
talk. Unless you have some more to kind of discuss, yeah, we can do that. Otherwise, we can try to close it.
Sure.
Okay, so because I also want to put some final words here. So yeah, thanks first of all for giving the talk. It was eye-opening and I enjoyed the work that you did.